For number 5, it says graph the equation in standard form. So we've got x and y on the same side. Then we have 12 on the other side. So I do the cover-up part where I say 3x equals 12. I divide both sides by 3, and x is 4. 6y equals 12. So I cover up the x. And I divide both sides by 6. So y equals 2. So then I need to put a point at 4 on the x and a point at y on the 2. And then I just connect them. In number 6, we're going to have to graph the inequality. So right here, this little line, the equal to, this means that it is solid. A solid line. And then this is greater than or equal to, so greater means that you actually shade above your line. You're also having to put your 1 in here for your slope. So I've got 1 over 1 for slope, and I begin at 5 on the y-axis. So there's 5 on the y-axis. Then I go up 1, right 1. But then I can also go down 1, left 1. And as you can see, there are many, many points for that one. And then I draw a solid line. And to shade above, I go back to where I began, and I draw a line up, and I see that this part is going up. So I shade the top part of the graph. In number 7, it says write an equation in slope-intercept form of the line containing the points of negative 11, 2 and negative 12, 7. So this one, I've got x1 and y1, x2 and y2, and at the beginning of Unit 3 we discussed this formula for slope. So now, when I solve it, draw my fraction bar with my minus signs, and then I go fill in my 4 numbers. So y2 is 7, y1 is 2, x2 is negative 12, and x1 is negative 11. So 7 minus 2 is 5. This becomes a positive, so negative 12 plus 11 is a negative 1. If I reduce that, that means that my slope is negative 5. I also know that my point is negative 11, 2. So these 3 different numbers here, we can plug into this equation, point slope form. So y minus y1, y1 is 2. The slope is negative 5. And then I have x minus x1, which is at negative 11. So again, that becomes positive. And then to go from PSF to SIF, I need to distribute. So I would have y minus 2, distribute your negative 5, distribute the negative 5 again, which means multiply, so negative 5 times 11, and then to get the y by itself, add your 2. But we know that these are different signs here, so that means you actually subtract those numbers, so that'd be 53. And I keep the sign of the bigger number. So this is the bigger number, so I keep the negative. Okay. In number 8, you have to multiply. Okay, so I'm going to distribute my 2 to the 7 and to the negative 9. So I have x to the 14th and then y to the negative 18th. But we discussed we can't keep the negative exponent. So we make a fraction by putting over 1. We keep the x, and then we move the 18, y to the 18th to the bottom, but you make it positive. Okay. In number 9, because we have that same base being divided, as you can see, then you actually are subtracting exponents. So 8 minus 3 is 5. 10 minus 2 is 8. And then for z, you're just subtracting the numerators. So 7 minus 1 is 6, but you keep that over the 8. And then if you can reduce the 6/8. So I can divide that by 2 and reduce that. So I would get x to the 5th, y to the 8th, and then z. If I divide 6/8 by 2, I get 3/4. Okay? And then the last one there on this page, we have -1, 0, 1 is what we always use. And then when we plug those in to here, we're going to have 3 separate math problems, okay? So first, if I plug -1 in, I only move the base that has a negative. So that 3 is on top, and then this 3 to the -1 goes to the bottom. But it becomes positive. So 3 over 3 becomes 1. Okay, now 0 I plug into x, and this part becomes a 1. So 3 times 1 is 3. And then for the last one, I plug 1 in for x, and 3 to the first becomes 3, so I have 3 times 3 is 9. And so if I graph that, -1, 1, 0, 3, and 1, 9 creates a curve.